simultaneous equations are two different things. Yeah, no, they're exactly the same thing.
Just maybe we didn't.
You didn't appreciate that then before. Okay. Well, you can now anyways. So what we'll do is we'll have a look at the different methods that you have for solving these, okay? So the first method is a method which you should not use in the exam, and that's the graphical method by using a graph. And why do you think I'm saying you should not use this in the exam? Takes time, and it's not accurate. It's not accurate. Right, so write this example down. You call them simultaneous equations, so you can call them simultaneous equations, or I prefer to call them degree 2 systems. 2 being that there's 2 equations. Right, so we'll have a look at the 4 methods. I have 4 different methods to show you, okay? So the first one is using the graph. So here's our example. Y equals minus 5x plus 9. Y equals minus 6x plus 2. It's much nicer having the big screen, isn't it? Much nicer. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Right, so I'm definitely missing 2 people then. Lambert? So I might see them shortly, yeah. Okay, did you write this down? Yeah. Actually, just before I do that, I said the word earlier, but I just want to make sure people know it. What is the name of this point where the lines meet? Intersection point, yeah. If you didn't know that. Yeah. Okay, so let's have a look at the graph method. Right, so no surprise here. The first thing we should do is draw a graph. So let me make a nice big graph here. Okay, x and y. So I can see that. What's the y-intercept for the first line? 9. So maybe I want to go up in 5s or something. I could make this 5, 10, 15. And maybe I won't go as big on the x. I don't think I need to. Maybe I'll just go up in 1s. 1, 2, 3, 4. I think that should be okay. So the first point, its y-intercept is here at 9. And can anybody see what the root is? You'll have to solve it. It's 0 equals minus 5x plus 9. So what does x equal? 9 over 5, isn't it? So that's 1.8. So that will be about here. It's going down. Not too bad. Right, and here, what's the y-intercept? It's 2, so I'll put it here. And if we solve this, 1.3. Let's have a look. Minus 2 divided 1 over 3, isn't it? Yeah. So that would be about here. Oh, this is gonna be ugly. So yeah, they're probably going to meet somewhere to the left. Yeah, so this is why you don't do it this way. Yep. Right. Okay. I've done it, so now I have to pick a value. I'm going to say minus 320. And this graph is ugly. The answer could have been down here. I don't know. Actually, I have the answer here. I will be shocked if this is right. See, this is 1e. I was off a little bit. In fact, the true answer is minus 7, 44. So it's a bit more up there. I was not too bad. It wasn't too bad. It's a little bit off, yeah. Go an extra 4 to the left and an extra 20 up. Yeah. Right, anyway, that's the graph method, which you can see not to use because it's just not accurate, okay? But it's good to see it because it's good to picture what you're doing. You're always trying to find where the two lines meet, okay? So the next method, which is really the first real method, I think someone said it earlier, we'll do substitution next. Okay, we'll do... Okay, this is the first real method. So substitution, the idea is this. Here, 5x minus 3 is the same as y, is equal to y. So that means here I can replace this y with the 5x minus 3, because 5x minus 3 is the same as y. So I can make this equation. 5x minus 3 equals minus 2x minus 3. Yeah, and then, in this case, the 3's would cancel, yeah. So you'd end up with, let me see, 7x equals 0. So x equals 0. Now, how can I get the y? I have the x, how can I get y? Yeah, well, you have two equations for y. You can use either of them. So, yeah, if you use it here, you'll get minus 3, and if you use it here, you'll also get minus 3. So you can see that the y equals minus 3. Which part? The y part, yeah. So what you do is you replace the x with your value you got here. So here you replace x with 0. So you get 0 minus 3 is the y. So the answer then is minus 3. Yeah. You probably saw this method in high school as well, right? Yeah.
So we take the y and then we substitute.
Solve, yeah. You replace the y and then you have, here's the key step. Now you have only x. You solve for x. Once you have the x, you just put it back in to get the y. Yeah. It's okay. I feel some confusion, but no, it's okay. Some of you saw this method in high school before. Now this method works really nicely here because you have y equals and y equals. But if I was to make it a little bit different, like if I said, here's another example, 2x plus 3y minus 5 equals 0, and then 3x plus 2y minus 5 equals 0. Yep.
You make y the subject.
That's it, yeah, that's it. You can make y the subject. You don't have to do it for both, actually. It's enough to do it for one of them. No, I'm going to do another substitution example. But in this case, you have to do some work before you can use it, you know. So like here, you could get y equals minus 2 over 3x plus 5 over 3. And then what do you do with that? Yeah, you substitute it here for the y. So then you get 3x plus 2y that's the y, minus 5 equals 0. Yeah, and then you solve this. Now this is not the best way to do this type. Somebody was talking about another method, which is what we should use. But the point I'm making is you can use the substitution method for this type as well. What do I need to do here? Just expand. So I get 3x minus 4 over 3x plus 10 over 3 minus 5 equals 0. Now this is 5 over 3x. 3 minus 4 over 3. No, not 5 over 3. Is it 5 over 3? 3 minus 4 over 3?
5 over, just 5 over 3.
Yeah, 5 over 3, yeah. 5 over 3x, and then this is 10 over 3, well, if I 10 over 3, minus 5 over 3? I think this is minus 5 over 3. Yeah? Yeah. So you can get 5 over 3x equals 5 over 3. Cancel, cancel, x equals 1. Now, how do I get the y? Just like before, I take the x and I'll put it back in, let's say this one. So that's minus 2 over 3 plus 5 over 3 is 3 over 3, which is 1. So I get y equals 1 then, when I replace it here. Yeah. So write this example down. This is another substitution method. So write this one down as well. Okay. Got that? Nearly? Okay. Yes? No, I'm waiting for at least 5 people. Okay. Before going on to the different methods, just want to again put the link in your mind that finding where 2 lines meet, and this type of problem is the same thing. So for example, 2x plus 3y minus 5 equals 0. 3x plus 2y minus 5 equals 0. I'm going to draw these beautifully. Let me graph. Okay, so there's the first line, and then here's the second line. And can you see that they do meet exactly at 1, 1, which is the answer that I got. Okay, so that's what we're doing. We're finding where 2 lines meet. Okay, so let's have a look at the next method now. Okay, somebody mentioned the name earlier. So this method is called elimination. Let's pick out an example.
So, the third method.
Yeah, this is the usual one. Let's say 7x minus 8y equals 5 and 4x minus 3y equals 6. You know this one? Yeah? Yeah. You have a choice. You can try and eliminate the x or eliminate the y. It doesn't matter. We'll go with the x. So you look at the x and you say, okay, I want these to be the same. If I want them to be the same, I need to multiply this by 4 and this one by 7. And now they're the same. The first one will become 28x minus 32y equals 20. And then the second one becomes 28x minus 21y equals 42. So now we have the x's the same. Yeah? Cancel the x's, yes. Yes, now, you have a choice here. You can add these two, or you can subtract these two. We must subtract. It wouldn't work to add, because if we add them, it becomes 56. So we don't add, we subtract. But you have a choice. You can do either. So, and also you can do 1 minus 2 or 2 minus 1. You can do them either way. So you can do top minus bottom or bottom minus top. Again, you have a choice.
When you do top minus bottom, the signs change.
Yeah, you might want to choose which one, because if you don't want to have minus signs, yeah. So I don't really mind. I'll just do top minus bottom. So that's gone. Now be very, very, very careful here. This is minus 32 minus 21, so it's plus. Yeah? So it's minus 32 plus 21. What's that? 11, isn't it? Minus 11. So minus 11y. And this is 20 minus 42, which is minus 22. So y has to equal 2. 2, yeah. Again, to find the x, we take our answer and put it back in. Which equation? Well, we can use any equation. Which is the easiest one? Second one looks nice. Has the smallest numbers in it. Yeah. So we'll put that in here.
We can use this method in all kinds of
Yes.
equations, right?
All these methods work for all types of these problems. Yes.
And
One sec, yeah.
the test, are you gonna require us to do one side?
Yes, that's possible in the test. The test may ask you to, usually not, but sometimes the test will ask you use this method to solve. So you do need to know all of them. Okay. 4x minus 6 equals 6, yeah? So 4x equals 12. So x equals 3. So that's the answer. 3, 2 is the answer then. This is the most common method to use. And if the exam asked you to use a method, they'd probably ask you to use this one anyways. So it's no big deal. Okay, make sure you write this one down. So this is your example of elimination. Any more methods? Not for this one, that'll be for the next one. Any other methods people know of? No? Are you sure? I can think of at least 2 more. Yeah, at least 2 more. That's like substitution method, so it's kind of the same. Anything else? Oh, I will. I'll teach you one more method at least, but I can think of 2 more, so I'm hoping somebody can give me at least one more method. No.
Could you simplify this? No.
Oh, come on. I'm sure somebody knows one more method. What about using a matrix? Some people know this method. Yeah. You remember this method, so you'd have like xy equals 2, 3, 1, 2 minus 2, 2 or something like this. You know this one? Anyway, relax, because this is not the other method I was going to show you, okay? So it's not this method I'm going to show you, don't worry. Now the last method I want to show you, it's another type of elimination, Gaussian elimination. Does anyone know this one? I don't think so. Yeah? No, I don't know this one. No. So anyways, please watch carefully. This one is a little bit difficult. The reason I want to show you this method is that this method works very well when you have very big and difficult problems. If you had like X, Y, Z, you know, or if you had, not for semester one. But the reason I'm showing you this is so that if you had a more difficult problem, you have this extra method. Now this method is not for the exam. It's just a method that you can use if you want to use, and it's really good method for difficult problems. You wouldn't, maybe you wouldn't use this method for simpler problems. Okay, so I'll show you how this method works. Can I scroll down a little bit? Yeah. So I'm going to pick a more difficult example, something kind of messy that has fractions in it, like 9 over 8x minus 5 over 8 equals 5 over 7 minus 3 over 4x plus 2 over 5y equals minus 1 over 5. It does not, which is actually good because it makes it much easier to do if it didn't. If the first one didn't have a y, then what would I do? Yeah, find x and then substitute it. Yes. Life's not that nice though. Okay. Please write it down carefully. I'll show you the Gaussian method now. Named after Gauss, yes. It is, yes. Yeah. Okay, you have this? Yeah. This method, even though it's not on the exam, like I said, it's a method that you can use if you want to, okay? Right. So the way this method works is you put these 6 numbers into a box. The 6 numbers here into a box. So you'd have 9 over 8 minus 5 over 8 5 over 7 minus 3 over 4 2 over 5 minus 1 over 5, and then close the box. Okay, so with this box, basically there are 2 rules. The first rule is that you can multiply any line by any number except 0. So for example, you could multiply this line by 5. You can multiply this line by 8, whatever. Okay, that's the first rule. The second rule is you can add any lines together and put the answer on any of the 2 lines. So for example, you could add this line and this line together and put the answer on this line or this line. Okay, so for example, you could do this plus this number and then put the answer up here. replacing this. You could do this plus this, and then put the answer up here. You could do this plus this, and then put the answer up there. Or the other way, you could do this number plus this number, and then write the answer here.
Leaving the upper numbers.
Leaving the upper numbers alone, yeah. So you can add two together, and then put the answer on either the top one or the bottom one.
So the rule has to be with each and everything in the line.
Yeah, it has. If you choose the top, then you have to put all the answers on the top. Or if you choose the bottom, you put all the answers on the bottom. Yeah. Now you'll see this when I do it as an example. Okay. And what you're trying to do is try to make the box become like this. Well, you know what? No, I won't tell. You'll see it when you get there. Okay. So our two rules: multiply by any number, and then add two lines together. So maybe we could do a multiplying first. You know, if you didn't want the 8s and the 7s and the 5s and the 4s, you could multiply. So what would be a nice number to multiply here by? 8, yeah, but if I want to get rid of the 7 as well. Is it 42? Maybe something a bit bigger than that. No. 56 would be best, yeah. Because 7 and 8 both go into 56. And what about here? 20. Yeah? Okay. Let's try that. So we'll take 56 and multiply it by the 3. And we'll take the 20 and multiply it by the 3 as well. So the top line, 63, I can do this, hang on, minus 35, 40. And then minus 15, 8, minus 4, when you multiply. Yeah?
What's the line for?
Huh? That's just representing the equal sign. You don't even need to write it. Yeah. Yeah? Continue? Yeah? Okay. Now, what I'll do next, and I'll need someone with a calculator, please. I'm going to multiply this one by 15 and this one by 63. You'll see in a moment. The magic will happen soon and all will become clear. So can someone give me the three numbers please on the top? 945. Okay, and then the next one minus 525. And then what's that? 500? No, 600. This one's minus 945. This one? 504. And this one? Minus 252. Now, can you see why I chose those numbers? What's happened? The first ones are the same. Now, let's remember our second rule. Is that right? Sorry, 252 you said? Yeah, okay. Remember our second rule. We can add or subtract any two lines together. So I should add the first line with the second line and put the answer on the second line. So for example, I keep the first line alone. Now let's add them together. When I add these together, what do I get? 0. When I add these together, what do I get? Minus something. Minus 19, is it? Can someone check that, please? It is minus 19? Because if there's one mistake, this will fall apart. And then here, 348? Is that right? Are we sure? Please double check. Yep. Adding them together. One of these is wrong? This one here? Minus 21? Here? And 25. 525 plus 504. Yeah, and the answer is minus 21? Yeah, okay. And is this one right?
Yeah.
We're adding them together. Yeah. Is the last one right as well? Should be. Yeah. Yeah, that's okay. Can you just check, can you divide this by 5, 10, 11, 12? I know you can divide it by 3. Can you divide it by 21? 525 divided by 21? Oh, great. So I'm going to divide both of these by 21. What did you get?
Which is the whole upper line.
Yeah,
Minus 25.
for the middle piece.
Yeah, minus 55 by 21 is minus 25.
What's the first one? 45. The second one is minus 25. And then the last one? We're dividing these three numbers by 21. Give it to me as a fraction if you have it.
Why are we dividing
Why? I'm just making the numbers smaller. Big numbers scare me.
112
Hang on. There's too many people giving me the answer. So, what's the first one here, did we say? 45. And this is minus 25. And the last one? 200 over 7. Thank you. And this is 0. This, of course, is minus 1. And then the last one is probably ugly as well. What is it? 116 over 7. Yes? I now would like to cancel here. So what could I multiply this by to make these the same? 25. What's the last number, please? 116 times 25 over 7 would be something very ugly. 2011. Sorry, 2,900 over 7. Okay. Now, I'm going to subtract them, minus them. Now, this is the last thing I'll do, and then you can see what has happened. I'm going to do the second line minus the first line and put the answer on the first line. I'll say that again. Second line minus the first line, put the answer on the first line.
When you put the minus over there, it was just minus.
Where?
No, above it you're in 25 for that box. For the one below, yeah, for the one below you're minus 1.
Here?
The euro at the side of the box you're in the 25, right?
Here's multiply 25, this one,
Below
yeah.
that's the answer.
But yes, this is the answer after multiplying by 25, yeah. Right. 45 minus 25, 200 over 7. 0 minus, sorry, wrong way, sorry. I'm keeping the bottom one the same. Okay, try that again. 0 minus 45, minus 45. Minus 25 minus 25, 0. And lastly, this number minus that number, that would be 2700 over 7. Yeah? Now, when you think about it, let's remember what this box represents. If we go back to the very start, this is 9 over 8x minus 5 over 8y equals 5 over 7. And this is minus 3 over 4x plus 2 over 5y equals minus 1 over 5. Yeah? So look at what we have down here. I have minus 45x equals this number. And then what about here? I have minus 25y equals this number. So, if I divide this by minus 45 and divide this by minus 25, what will I be left with? I'll have a 1, 0, 0, 1. And these two numbers here, will be the answer. Because this will be 1x plus 0y. What's 1x plus 0y? X. 0x plus 1y. Y. So the moment I divide these numbers by 45, that's the two answers. So what's this divided by 45 and this divided by 25? They both be a minus. Minus 60 over 7, and the other one?
Basically, you're trying to make it all zeros.
Now listen. It's not easy, but if you remember, I never said this week or last week that anything I would do would be easy. Yeah? And if you thought I said that, you are badly mistaken. Okay? Now it's difficult, and it's difficult because it's new. What? I know, but the reason I'm showing you is because when you have bigger problems like with X, Y, and Z, it'd be quicker to do it this way. Trust me. So I'll finish with one quick example with X, Y, and Z, just to show you, because you don't believe me, but that is okay. Right. So here's my three equations. X plus Y plus Z equals 3. 2x plus y plus 2z equals 5. 3x minus y minus z equals 1. Now, it's not as bad as it looks. You remember these problems from school where you have x, y, z? Some of you do. Okay, write this down, and we'll go through this. Can I go down? Yeah. 1, 1, 1, 3. What will be next? 2, 1, 2, 5. And lastly, 3, minus 1, and 1. So you have 3 of them. Yes? We'll do it together. Okay? Now, I'm going to do it quickly. If you can't keep up, that's okay, because you can watch the video. Alright?
Where do you post these videos? On YouTube?
On YouTube, yeah. If you go to Moodle, there's a link to the channel then. So the video from this morning is already there. You should subscribe to my channel, and then you will get an email when the video's been uploaded. I'm trying to get to 100 subscribers. At the moment I have 80.
100?
Yeah. Yeah, that's what I aim to. I only started the channel recently. If I get to 100, I'd be happy. Yeah.
Do you record your voice as well?
Everything's recorded. It wouldn't be so useful if there was no sound. Yeah. Okay. Let's have a look at this. So, what you do first is you try to make all these numbers the same. So we'll go with 6 is the smallest I can think of. Multiply 6, multiply 3, multiply 2. So we'll get... Yeah. No, I should make it clear that what you're trying to get to at the end is 1, 0, 0, 0, 1, 0, 0, 1, 1. So the way you deal with this is you start first with this column. You try and get your zeros there. Then you move to the next column. You try and get the zeros there. And then you move to the next column and you try and get the zeros there. You'll see how I can get the zeros, because if this becomes 6, 6, 6, 21... No, 18, and this will be 6, 3, 6, 15, and this will be 6, minus 2, minus 2, 2. Now, which do you want to make 0? You want to make this and this a 0, right? So what, no talking please, no talking. So you want to make this and this a 0, so you should do row 1 minus row 2, and where should I put the answer? On row 1 or row 2? I should put on row 2, and this will become 0. 6 minus 6? 0. I want the answer to go here. I will, don't worry. And I should do row 1 minus row 3. And where should I put the answer? On 1 or 3? Row 3, yes, that's it. So let's do that. The first one I keep the same. 6 minus 6, 0. 6 minus 3, 3. 6 minus 6, 0. 18 minus 15, 3. And then 6 minus 6, 0. 6 minus minus 2, 8, 16. Now look, you already have 2 of them here, and you have 1 of them here. So now you're trying to make zeros here, here, and then here. You have 3 left to make. Okay, so... Yeah? 6 minus minus 2 is 8. 18 minus 2, 16. Yeah? Right, who has an idea on how I can make this one 0?
Between 6 and 8, right?
Yeah, you want these two to be 0. Well, it's much easier if you can make them all the same. Then when you add and subtract, what happens? They disappear. So what's the smallest number here? 48, isn't it? You want to try and get them all to 48, isn't it? So you could multiply this one by 24, this one by 48, and this one by 18. Then what will happen is they'll all be the same. Then you can minus again, and you make this and this 0. And then in the last one you can do the same thing as well. So if you have a calculator, maybe we'll just finish with this. Yeah, 6 times 24. What is it? Yeah, and I know that these will all be 144 if I did that right in my head. 60. No, not 608. It's not a 6 here. 6 times. This is 144. This is 144. This is a big number. Oh, thank you. 432. That's still a 0, and that's 144. That's 0. That's 144. That's 144. And this last one? 288. Great. Now, what should I minus now? Row 1 minus row 2. And where should I put the answer? No, on row 1. I want to make this 0. And if I want to make this one 0, row 1 minus row 3 and put the answer on row 3. So now watch it all simplify. 144, 144, 144, 432. Row 1 minus row 2. No. Hang on, I got confused. Hang on, I got confused. Number. Row 1 minus row 2. Yeah, sorry. I realise now. Right, row 1 minus row 2. So 144 minus 0, 144. 144 minus 144, 0. 144 minus 0, 144. 432 minus 144, please. 288. And then this is 0, 144, 0, 144. And then row 1 minus row 3. 144 minus 0. No, I'm rushing for this. I have a meeting at 3 o'clock, that's what I'm thinking about. Right, no, forget about it. I don't have time to finish it. I'll have to do it next time. Right. Yeah.
Did you show us the
No, just pretend you didn't see that last bit, and I'll do it again next time, okay? Yeah. For your homework for this, not for this bit, relax. Question 1, 2, and 3, A and B. 1, 2, 3, A and B.
So that's from the third worksheet.
Yeah. Now, if you want to try number 4, which is this type, you may. But number 4 is completely optional because it's not on the exam. Which, I realise when I say it's completely optional, in your brain you hear, I don't have to do it.